Good morning. This lesson is for my Honors Integrated 1. This is section 2.1 out of our book. Before I get started, I want to say I hope everybody's doing okay out there. So again, the way that I'm going to teach these lessons is I'm not going to teach exactly how it's out of the book. We're going to have 4 ideas that I'm going to teach about, and somehow, some way, these 4 ideas are going to be the ideas that you need to answer all the questions on our HRW assignment that you're going to answer online. So let's just go ahead and read our goals. The first one is we're going to define terms and coefficients. Our second goal is we're going to set up expressions. Our third goal is percent and the distributive property, and our fourth goal is comparing unknown values. So I'm just going to go ahead and jump right in. I'm going to try and keep this as simple as possible. And hopefully this will be good enough for you guys to do all of the homework. So our first goal is defining terms and coefficients. Terms are the parts of an expression being added. Coefficients are the numbers that are multiplying the variables. So right here, I have this whole thing, 3x minus 4y. This is called an expression. So that's what an expression would look like. It's 3x minus 4y. Now, in the definition of term or terms, it says that they're being added together. So I could actually consider this to be 3x plus negative 4y. And so I would say the terms of my expression are 3x and negative 4y. And the coefficients are the numbers that are multiplying the variables, and the coefficients would be 3 and negative 4. Pretty simple first goal. I'm going to go ahead and check that off. All right. Let's move on to our second goal. Our second goal is to set up expressions, set up something that looks like this. And I have 2 statements. I have a statement that shirts are $10 and hats are $5. And so I want to build a pattern here, right? I want to just talk about buying shirts. So if I buy one shirt, it's $10 times 1, which is 20 bucks. If I buy 2 shirts, it's $10 times 2, which is 20 bucks. If I buy 3 shirts, it's 10 times 3, 30 bucks. Now, if I was to, let's say, buy an arbitrary amount, I would say, let's say I bought an X number of shirts, right? I would say that I'm buying, or it would be 10X. So this would represent how many shirts I bought at $10, but that actually represents how much I spent buying X number of shirts. So we would consider this the amount spent buying X number of $10 shirts. And the same thing would be true for buying hats. If I bought one hat, it would be $5, or 5 times 1. If I bought 2 hats, it'd be $10, or 5 times 2. If I bought 3 hats, it would be 5 times 3. Let's say I bought a different number of hats. Let's say I bought a Y amount of hats. So that means that I would have the term 5y, where this is the amount spent buying a Y number of hats. The amount spent buying a Y number of $5 hats. Now, if I was to put a plus sign between these, I now have an expression. And this expression represents how much I spent buying X number of hats and how much I spent buying a Y number of $5. Did I say hats? This represents the amount that I spent on the X number of $10 shirts and a Y number when I bought a Y amount of $5 hats. Altogether, this represents how much we spent. Alright, so hopefully I didn't get hats and shirts mixed up too bad. Alrighty, so I'm going to check off our second goal. Our third goal, percent and the distributed property. So, percent means per 100, right? And if I think this will be helpful to think about money. 5% of a dollar is 5 cents. And when we talk about percent, it's usually related to either sales tax, which means that you're adding amounts to the purchase because tax is a fee for doing business, or it could be considered a discount, like the amount off. The hats were 20% off, so you're deducting a percent or amount per 100, right? And so we think about percent as in money. So 5% off means that we take 5 cents off for every dollar we spend. Or 8% sales tax means that we add 8 cents for every dollar we spend. A 20% discount means that we take 20 cents off the price for every dollar that item is being sold. And so let me set up here just a little bit of an idea. So let's say that for example, let's say I was going to write with the same color. I keep that theme going. Let's say that you're going to buy a $10 shirt and sales tax is 7%. $10 shirt plus 7% sales tax. All right. So what that means is for every dollar that we're going to spend, we're going to add 7 cents to that dollar. And so we could actually think of this as $1 plus 7 cents, or actually we're going to want to leave it like this. We're going to want to leave it like this. So $1 and 7 cents. Now, I am spending $10. Okay? So it's kind of like when I was setting up the expressions, right? But the thing I know that students will have an issue with is adding or subtracting the percent, right? 7% sales tax means it's 7 cents for every dollar, okay? So the next thing that we're gonna do, just to finish this, is we're just gonna multiply this out. Distribute. So that means that the cost of a $10 shirt at 7%, with 7% sales tax will be 10 times 1, which is 10, plus 10 times, or parentheses around 10 times 0.07. So this is how we would calculate the cost of a $10 shirt with a 7% sales tax. All right. Yeah, this is probably going to be one that we need to spend a little bit of time talking about. It takes a little practice, but it's going to be a mathematical concept that you're going to deal with for the rest of your life. So that's okay if we struggle on this one a little bit. We'll get the hang of it. All right, the last goal is to compare unknown values. And so you're going to see in this homework set something like this. X and Y are ages where X is larger than Y. And they're going to ask you something like this. 1 over X, how does that compare to 1 over Y? So these questions are, I remember when I started seeing these questions in high school, I really had a hard time wrapping my mind around how to answer this question. Is 1 over x bigger than 1 over y? Is 1 over x smaller than 1 over y? Or is 1 over x equal to 1 over y? And so I would look at this problem and I would think, well, okay, I don't know what x and y are, but I can create numbers that would make this true, right? And so, I would say maybe, I'm just going to say maybe x is 2 and y is 1, and I would put, how does 1/2 compare to 1 over 1? Which is 1/2 compared to 1, because 1 over 1 turns into 1. And so I would realize, oh, okay, 1/2 is smaller than 1. So with this, with these types of problems, I'm going to say it's actually really helpful to pick values to plug in. And then that way you can work out the problem and see what we're supposed to get. So this is going to wrap up section 2.1. Again, these are the ideas that you need to answer the homework. I'm not doing specific problems from the homework. I'm teaching you about the tools, and you have these 4 tools that that we learned about in this lesson that we can answer the questions for the homework. So again, I hope everyone's doing okay out there. We're probably going to need a little bit more help on the percent. I might just make another video on percent, just because it is such an important numerical concept in this economy of ours. So again, I hope everyone's doing okay. I will see you guys later. Have a good day.